we will discuss about numericals on work, power, energy and friction. When we study about these chapters, then for doing the numericals, first thing that comes in our mind is that what are the formulae that are required when you solve problems pertaining to work, power, energy and friction. So, we should know about the list of formulae that has to be used. Now, what is work done? You might have studied that when a force acts on a body and moves it through some displacement in the direction of force, we say work is done. The formula to calculate work done is dot product of force and displacement. You take the component of force along displacement or you take the component of displacement along force. So, you get F cos theta into S or F S cos theta. If both force and displacement are in the same direction, then angle between force and displacement is 0 degrees. So, work done is F S. Secondly, when you calculate energy, you should know the formulae of kinetic energy as well as potential energy. Kinetic energy, energy due to motion of a body. The formula used is half m v square. Potential energy, formula used is mass of the body into acceleration due to gravity into height. Then work energy theorem. You might have studied that the amount of work done by a force on a body is equal to the change in kinetic energy of the body. The formula is that work done is final kinetic energy minus initial kinetic energy half mv square minus half mu square. Then friction, a force that comes into play whenever there is a relative motion between two bodies. Force of friction, rather limiting friction, is given by mu into r, where mu is the coefficient of friction and r is the normal reaction. Over a horizontal surface, normal reaction is equal to weight of the body and weight of the body is equal to mass into acceleration due to gravity. So, the formula for friction becomes mu mg. When you do calculations over a rough inclined plane, you see on your screens a rough inclined plane, a body of mass m is placed on it. Let us say it is at an angle theta to the horizontal. Then the weight of the body shown as Fg with the black arrow acts always in the downward direction. So, this arrow gives the force due to gravity, which we call as weight. Then this is the component in the perpendicular direction, this is the component in the parallel direction, parallel to the inclined plane. So, if you see a person here skiing downwards, the various forces have been shown. This is the weight of the body always in a perpendicular direction. Then this is the perpendicular component of weight, this is the parallel component of weight. N stands for normal reaction. Normal reaction, remember, it is always normal to the body. Weight is always in a direction, in the downward direction towards the center of gravity, and normal reaction is normal to the body. Force of friction is always opposing the motion. So, if the motion is the downward direction, then force of friction is in the upward acceleration, upward direction. So, the person will accelerate downwards. Again, this is how the body accelerates down an inclined plane. Again, the various forces are shown for a block, the weight acting in the downward direction. There are two components of weight, one is perpendicular component, other is parallel component. Perpendicular component is given as W cos theta because the angle is made here. So, the base is this. So, this is the perpendicular component, this is the parallel component, parallel to inclined plane. So, when I say parallel component means parallel to the inclined plane. When I say perpendicular means perpendicular to the inclined plane. So, what you see here is that W sin theta is a component of weight down the inclined plane. This is force of friction. Fk stands for force of kinetic friction. So, the body will move downwards if this force W sin theta is greater than this force, that is Fk. So, let us see in the next slide. Again the picture is shown here. What is W? W is the weight of the body, and as I told you, weight of the body is mass into acceleration due to gravity. So, this component W sin theta is mg sin theta. So, what is the net force downwards? Net force downwards, नीचे ਨੂੰ ਕਿੰਨਾ net force है, ਤੁਸੀਂ W sin theta ਚੋਂ force of friction minus कर दीजिए. Force of friction कितना सी? mu into r. So, net force is equal to mg sin theta minus mu r. When we say net force means mass into acceleration. So, mass goes off. So, acceleration of the body down an inclined plane is given as g sin theta minus mu cos theta. Now, if you want to find out the work done up a rough inclined plane, अगर असी किसी body ਨੂੰ inclined plane ਦੇ ਉੱਪਰ ਨੂੰ ਭੇਜਣਾ ਹੋਵੇ ਤਾਂ ਤੁਹਾਨੂੰ force apply ਕਰਨਾ ਪਏਗਾ. Force apply ਕਰੋਗੇ ਤਾਂ कम होएगा, work done होएगा. So, if a body is to move upwards, as this child is trying to move upwards on the inclined plane making an angle of 35 degrees. So, weight of the child mg is in the downward direction. Again, these are going to remain same, perpendicular component mg cos theta, and this is the component parallel to the plane. So, it is mg sin theta. Now, the body is moving upwards. So, the motion is upwards, then where will be the force of friction? This is the force of friction. Force of friction will be in the downward direction. Remember that force of friction always opposes the motion. जिधर ਨੂੰ motion हो रहा है, frictional force उसਦੇ हमेशा उल्ट होएगा. अगर body नीचे ਨੂੰ आ रही ਸੀ ਤਾਂ frictional force ਉੱਪਰ ਨੂੰ है. ਹੁਣ ਅਸੀਂ body ਨੂੰ ਉੱਪਰ ਨੂੰ ਭੇਜਣਾ है ਤਾਂ frictional force नीचे ਨੂੰ ਹੋਏਗਾ. This means frictional force भी अगर ਤੁਸੀਂ ਇੱਥੇ ਦੇਖੋ frictional force भी नीचे ਨੂੰ है और weight ਦਾ component ਜਿਹੜਾ ਹੈ parallel component है ਇਹ भी नीचे ਨੂੰ है. दोनों कंपोनेंट्स इक्को डायरेक्शन च हैं नीचे ਨੂੰ. दिस मीन्स ये दोनों कंपोनेंट की करनगे ऐड कर जाएंगे. सो बोथ द कंपोनेंट्स ऐड अप एंड गिव यू mg sin theta plus mu r. सो टोटल फोर्स इज mg sin theta plus mu r. And what is r? If you see here, this is the normal reaction. Normal reaction is equal to the perpendicular component mg cos theta. So, r is mg cos theta. So, if you want to displace a body through a displacement s, then work done is mg sin theta plus mu cos theta into s. So, these are the formulae that you should know before you start dealing with the numerical problems on work, power, energy and friction. Now, let us take up the numericals. First numerical. A box is pushed through 4 meter across a floor offering 100 Newton resistance. How much work is done by the resisting force? So, first of all, when you deal with the numericals, you read the numerical carefully. Find out what are the things that have been supplied to you. So, here what is given to you? 100 Newtons. He says the resistive force is equal to 100 Newtons. ਹੋਰ ਕੀ ਦਿੱਤਾ ਹੋਇਆ is numericals? Displacement. Box is pushed through 4 meter. ਸਾਨੂੰ displacement ਦੇ ਦਿੱਤੀ 4 ਮੀਟਰ ਦੀ displacement ਰਾਹੀਂ box ਨੂੰ push ਕੀਤਾ ਗਿਆ. Find out ਕੀ ਕਰਨਾ ਹੈ? Work done ਕਰਨਾ ਹੈ. ਕਿੰਨਾ ਕੰਮ ਕਰਨਾ ਪਏਗਾ? तो angle कितना है? You see, if you again read the question, box is pushed through 4 meter offering 100 Newton resistance. This means the case is of a horizontal plane. The body is lying on a horizontal plane. So, angle is 0 degrees. So, work done, you know, it is F dot S, and again angle is 0 degrees. So, F S cos 0 is 1, gives you F into S. So, simply multiply force with displacement, you get 100 multiplied by 4 equal to 400 joule. This is a simple numerical to calculate the work done by the resistive force. Now, second question. A body moves through a horizontal distance of 12 meter under the action of a force of 5 Newton. Calculate the work done if the force makes an angle of 30 degrees with the horizontal and 60 degrees with the horizontal. Again, read the question carefully. What quantities are given to you? You see, you are given force. How much force? 5 Newton. So, note it down. Then you are given distance. How much distance the body has been moved through is 12 meters. Then you are given in the first case the angle with the horizontal, which is given to you as 30 degrees. So, all quantities have been given. Now, it is simple to calculate work done. So, work done is equal to what? F dot S, F cos theta into S, F S cos theta. Put the values. F is 5 Newton, S is 12 meter, theta is 30 degrees. You get 5 into cos 30 into 12. Remember what is cos 30? It is under root 3 by 2. 12 into 5 gives you 60. Your answer comes out to be 30 under root 3 joule. And under root 3, remember this is simple, 1.732. Remember under root 2 also 1.414. तो जो simple square root quantities ਹੁੰਦੀਆਂ ਹਨ ਇਹ ਸਾਡੇ ਯਾਦ ਰਹਿਣੀਆਂ ਚਾਹੀਦੀਆਂ ਨੇ. Under root 3 1.732. The answer comes out to be 51.96 joule. Now, the second part of the question, you see, the only change is that of the angle with the horizontal. In the second part, you are given angle to be 60 degrees. Again, I will write down what is given to you. Force has been given to you as how much? 5 Newton. Then distance has been given to you as 12 meter. This remains the same as that in the part 1 case. Angle changes. Angle is 60 degrees here. Work done. The formula remains same. F dot S, F cos theta into S, F S cos theta. Put the values. What is F? F is 5 newtons. Theta cos 60. 12 the distance. So, your answer comes out to be 12 into 5, which gives you 60. Cos 60 is half. You get 60 into 1 by 2. You get 30 joule as the work done. Next question. How much work will be done in dragging a body of mass 100 kg through a distance of 100 meter on a level road, means horizontal road, if coefficient of friction is 0.2. Again, first of all, what you have to do is, when you solve the numerical, you note down all the quantities that are given and note down what you have to find out. ਤਾਂ ਪਹਿਲੀ ਲਾਈਨ ਸਾਨੂੰ ਦੱਸ ਰਹੀ ਹੈ ਕਿ ਅਸੀਂ ਲੱਭਣਾ ਕੀ ਹੈ, ਹਾਊ ਮਚ ਵਰਕ ਵਿਲ ਬੀ ਡਨ. ਤਾਂ ਅਸੀਂ ਕੀ ਕੈਲਕੂਲੇਟ ਕਰਨਾ ਹੈ, ਅਸੀਂ ਵਰਕ ਕੈਲਕੂਲੇਟ ਕਰਨਾ ਹੈ. ਸਾਨੂੰ ਦਿੱਤਾ ਕੀ ਹੋਇਆ, ਡਿਸਟੈਂਸ ਕਿੰਨਾ ਮੂਵ ਕੀਤਾ ਹੈ, 100 ਮੀਟਰ. ਮਾਸ ਕਿੰਨਾ ਹੈ, 100 kg. ਤਾਂ ਨਾਰਮਲ ਰਿਐਕਸ਼ਨ ਕਿੰਨਾ ਹੋ ਜਾਊਗਾ, ਜੀ ਸਾਨੂੰ ਪਤਾ ਹੀ ਹੈ 9.8 ਹੈ, 100 into 9.8. Coefficient of friction is given to you as 0.2. So, you can find out the force of friction, which is equal to mu into r. Force of friction is equal to mu into r. So, r the value ਦਿੱਤੀ ਹੋਈ ਹੈ 980 newtons. Mu is 0.2, multiply 0.2 by 980, you get 196 Newton. So, this is the force of friction against which you are trying to drag the body. So, if you have to drag this body, now I have to find out the work done. So, minimum amount of force that you will have to apply is how much? Which is equal to force of friction, that is 196 newtons. So, work done will be how much? The force that you will have to apply, force किदे against apply करोगे? Force of friction ਦੇ against. This means कि घट्टो घट जिहड़ा force सानू लाना पेगा अगर असी उस body ਨੂੰ drag करना है तो force of friction ਦੇ बराबर होएगा. तो कितना force लगाना पेगा? 196 newtons. और displacement कितनी हुई है? 100 meters. So work done is force into displacement 196 into 100, which gives you 19600 joules. Next question. A laborer whose own mass is 50 kg carries a trunk of mass 40 kg to the top of a building 8 meter high in 2 minutes. Calculate total work done by him and power developed by him. Now, you see what is given to you. First thing in the first line that is given to you is mass of the laborer. What is the mass of the laborer? 50 kg. In the second line, you are given mass of the trunk. What is mass of the trunk? 40 kg. Then in what is the total mass that you have to the laborer has to carry? It is his own mass plus the mass of the trunk. M1 plus M2, 50 plus 40. So total mass जिहड़ा lift कीता हैगा laborer ने वो किन्ने kg है? 90 kg है. Then in the second line again if you read, you are given the height of the building. So height through which he had to move this mass is 8 meter. And you are given the time. How much time is given? 2 minutes. Now remember to convert minutes into seconds. We are using SI system of units. So in SI systems, time is to be taken in seconds. So minute ਨੂੰ second ਦੇ ਵਿੱਚ convert ਕਰ ਲੀजिए. मास अगर ਤੁਹਾਨੂੰ ग्राम ਚ ਦਿੱਤਾ ਹੋਇਆ ਤਾਂ ਉਹਨੂੰ ਵੀ ਕਿਲੋਗ੍ਰਾਮ ਚ ਕਨਵਰਟ ਕਰਨਾ ਹੁੰਦਾ ਹੈ. ਮੀਨਸ ਹਰ ਇੱਕ ਕੁਆਂਟਿਟੀ ਤੁਹਾਡੀ SI ਸਿਸਟਮ ਦੇ ਵਿੱਚ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ. You have to find out the work done. The laborer lifts this. So total work done is equal to force into displacement. So you should find out the force against which work has to be done. What is the force against which work has to be done? It is the total mass into acceleration due to gravity. So the force against which work is done is mg. Total mass is 90. 90 into 9.8 will give you 882 newtons. So total work done is the force against which work has been done multiplied by the height through which the body has to be moved, mg into h. Height कितनी सी? 8 meter और force कितना लभ्या सी? 882. This comes out to be 7056 joules. Now you have to find out the power developed. कितनी power develop करेगा? Power किहदे बराबर हुंदी है? Work done per unit time. Work done is how much? If you see on the upper line, it is 7056 joule. Time, if you have noted in your notebooks, time is 120 seconds. So 7056 divided by 120 gives you 58.8 joule per second or 58.8 watt. So power developed is 58.8 watt. Now let us take up the next question. He says calculate kinetic energy of a ball of mass 0.1 kg when it is thrown with a speed of 15 meter per second. So you are given the mass of the body. First of all, note down all the quantities in your notebooks which are given to you. Mass m is 0.1 kg. Speed v is 15 meter per second. ਤੇ ਅਸੀਂ kinetic energy ਦਾ ਫਾਰਮੂਲਾ ਕਿਉਂਕਿ ਕੀ ਹੈ ਹਾਫ mv ਸਕੁਅਰ. फाइंड आउट की करना है kinetic energy. सानू m भी दिता है तो सानू v भी दी हुई है, स्पीड भी दी हुई है और मास m भी दिता हुआ है. सो मास इज 0.1 kg, velocity is 15 meter per second. So simply put the values, half into 0.1 into 15 square. You will get the answer as 11.25 joule. So, numerical ਕਰਨ ਵੇਲੇ ਸਭ ਤੋਂ important thing that you have to keep in mind is that you have to read the numerical. If you are unable to understand it, read it again, read it 2 times, 3 times and note down what is given to you, what you have to calculate. You will feel that solving a numerical is very easy. Next question. A block of mass 2 kg moving at a speed of 10 meter per second accelerates at 3 meter per second square for 5 seconds. Compute its final kinetic energy. So, we are given the mass of the body. Mass is 2 kg. Initial velocity is 10 meter per second. Acceleration is 3 meter per second square. And time for which it accelerates is 5 seconds. This means you will have to find out the final velocity first and then you can find out the final kinetic energy. So, here are the quantities that are given to you. Mass of the ball or the block 2 kg, initial velocity 10 meter per second, acceleration 3 meter per second square, time 5 seconds. Which formula will you use? You remember equations of motion. There are 3 equations of motion. From these 3 equations of motion, you will use the equation V equal to u plus at. What is u? It is given to you 10. What is a? 3. What is t? 5. 3 into 5 gives you 15. 10 plus 15 gives you 25 meter per second. So, you have computed the final velocity of the block and once you have calculated the velocity, you can calculate the final kinetic energy because your formula for final kinetic energy is half mv square. M is 2 and V is 25. 25 square gives you 625. So, your final kinetic energy is 625 joules. Next question. Calculate work done in lifting a mass of 5 kg through 8 meter. Take g equal to 10 meter per second square. Now, here you have to lift a mass. When you have to lift a mass, you have to go against the force of gravity. So, how much force should one apply? That should be equal to the force of gravity, that is m into g. Once you calculate this, you multiply this force with height, you get work done. So, first of all note down the quantities which are given to you. You are given mass m equal to 5 kg, height h equal to 8 meter, g equal to 10 meter per second square. So, once you have noted these down, try to bring the formula in your mind. What comes to your mind? That the formula that fits here is mg is the force of gravity. So, when you have to lift the body upwards, you will have to apply a force which is equal to force of gravity m into g. और डिस्टेंस कितने राही मूव कर रहे हो? जो हाइट दी हुई है 8 मीटर. सो वर्क डन इज इक्वल टू पोटेंशियल एनर्जी and this is equal to mg into h. Put the values, m is 5, g is 10, h is 8, you get your answer 400 joules. Next question. The mass of a cyclist together with the bike is 90 kg. Calculate increase in kinetic energy if the speed increases from 6 km per hour to 12 km per hour. Now, what you are given is, you are given the mass of the cyclist plus that of the bike. What you have to find out? Increase in kinetic energy, means change in kinetic energy, means final kinetic energy minus initial kinetic energy. Kinetic energy ਦਾ ਕੀ ਫਾਰਮੂਲਾ ਸੀ? ਹਾਫ m into v square. ਤਾਂ ਸਾਨੂੰ velocities ਵੀ ਦਿੱਤੀਆਂ ਹੋਈਆਂ ਨੇ, ਮਾਸ ਵੀ ਦਿੱਤਾ ਹੋਇਆ ਹੈ. We have been given initial velocity as 6 km per hour. Total mass तो 90 है. Initial velocity 6 km per hour. When you have to convert kilometer per hour into meter per second, simply multiply by 5/18. ਜਦੋਂ ਕਿਲੋਮੀਟਰ ਪਰ ਆਰ ਨੂੰ ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ ਕਨਵਰਟ ਕਰਨਾ ਹੈ ਤਾਂ 5/18 ਨਾਲ ਮਲਟੀਪਲਾਈ ਕਰ ਦੀजिए. So 6 km per hour means 6 into 5/18 will give you the value as 1.666 meter per second. Convert 12 km per hour also into meter per second. So multiply it by 5/18. This gives you 3.333 meter per second. So what will be the increase in kinetic energy? Final kinetic energy minus initial kinetic energy. Final kinetic energy is half mv square. Initial kinetic energy is half mu square. M is 90. So put the values, do the calculations. Your result will show that the increase in kinetic energy is 374.8 joules. So values put कर दीजिए, स्केयर कीजिए 3.333 और 1.66. Calculate this value, you get 494.5. Second value you get as 124.6. Final answer you get as 374.8 joules. So this is the increase in kinetic energy. Next question is, a car of mass 750 kg on a flat ground increases its velocity from 20 meter per second to 30 meter per second. What was the work done by its engine? If you remember, at the start of this lecture, I had given you a formula which was relating energy with work and which you might have studied in your theory part, called work energy theorem. Work done on a body by a force is equal to the change in the kinetic energy of the body. This is what is called work energy theorem. So you see, what you are given in this numerical is, you are given the mass of the car. Mass of the car is 750 kg. Numerical pertains to work energy theorem. Mass is 750. Initial velocity 20 meter per second. So initial kinetic energy is half m into initial velocity square. M is 750. Initial velocity is 20 square, and this calculation will give you 150,000 joules. Then you have to find out final kinetic energy. You are given the final velocity 30 meter per second. So final kinetic energy is half mvf square, half into m, mass is 750, final velocity is 30 square, it gives you 337,500 joules. Then what is change in kinetic energy? Change in kinetic energy is final minus initial, 187,500 joules. This is the work done. This is called work energy theorem. Next question, find the average frictional force needed to accelerate a car weighing 500 kg in a distance of 25 meter. So you have to find out the average frictional force to accelerate, to make the car move in a distance of 25 meters. What you are given is mass 500 kg, distance through which the car has to move 25 meters, initial velocity 20 meter per second, formula minus a equal to v square minus u square over 2s. Find out acceleration here, find out the frictional force, mass into acceleration. and you get the answer. Next question. A worker pushes a 50 kg crate by a distance of 7.5 meter across a level floor. He pushes it at a constant speed